My name is Jawad Rafi'i.
My name is Casey Hoffman.
My name is Jiuru Xu.
My major is mechanical engineering.
I'm a mechanical engineering PhD student.
I'm a PhD student in physics.
And I'm from Tehran, Iran.
I'm from Handan, China.
And I'm from Kempton, Pennsylvania.
My project is dealing with inventing a new material or a new process for storing the hydrogen for fuel cell cars.
My project is specialized elastomeric tooling for advanced thermoset composites. It's a way to cure some of these high-tech materials that are used in industry.
My project is about solving the efficiency joule problem in LEDs.
You know, we are a middle-class family, and then my parents, they didn't have college education, so that's one of the reasons they encouraged us to go to the college. Although I didn't have a college education, I learned a lot from them. My mom is a little bit tougher. My dad always was saying, don't waste the time. Time is important.
Without a doubt, my mom has been my biggest supporter. Phone calls, checking in, just always showing interest in everything that I do.
When I was a kid, I'm always helping my father around. Just hold this plate for me, kid, something. And my mother is my first teacher. She taught me just from the very beginning, the words, the basic math, and she also liked to show me around different landscape, different culture, different tradition, just to kind of explore myself, to open myself to the whole world.
I like to do anything outside, anything that gives me an excuse to be not stuck inside, anything outdoors. I really enjoy fishing, boating.
When I was a kid, my favorite book is not any novel, it's not any fairy tale, but it's a book called Hundreds of Thousands of Why. Why should be that way, so why? It's kind of, they intrigue me they lead me to ask questions, to understand things.
My younger brother, Kian, is 3 years younger than me, and we grew up together. We have a lot of things in common. We talk about the scientific project together at home, at school. When we go get a coffee together, we go together to gym, and everybody see us, they're confused who is who.
I think I first became interested in science either in middle school or high school.
He's very good with experimental work, with hands-on work.
Taking physics classes and just a general interest in science and smashing things, blowing things up.
He's very outgoing, which is nice. You don't see that with engineers. He's very good with people.
I was kind of prying my physics teacher, asking why? And he was saying to me, okay, if you really want to know why, just go to college and choose physics as your major.
I'm very interested in multidisciplinary problems.
His passion for research, you can't teach that. Right? When you hire a grad student, either the person has it or doesn't have it. Right?
Different angles, chemistry, physics, mechanics, engineering viewpoint.
That passion and love for research, for writing papers in very good journals, top journals, that is something that he intrinsically always had from day one.
It's a way of curing these advanced composite materials, which are made up of high-strength fibers such as Kevlar or carbon fiber. They're typically used in a lot of different industries, including aerospace, medical, energy. There's a huge need in industry today for out-of-autoclave curing technologies. Typically, the way these parts are made in industry today requires insanely long, time-consuming processing steps, and also large industrial autoclaves, which are pressurized heated vessels. And they're extremely expensive from a capital standpoint, and also they're very inefficient in terms of energy. My technology is a way to manufacture those parts. Those fibers are encased in a polymer resin, which is referred to as thermoset because it cures at a given temperature over a period of time.
The name of my project is Graphene, a revolutionary material for hydrogen storage. Graphene, this material came a couple of years ago and it's a very new material. My project is invention of a new process for making bulk production graphene in a cheap way to meet all the goals of hydrogen storage, which are room temperature storage, low pressure, safe, easy absorb and release the hydrogen. Meeting all these goals and to be applicable for mass production of cars.
Well, currently, the LEDs are good at low power applications such as cell phone screen lighting, but at high current,
desk lamps, room lights, street lights, headlights for cars.
when we want to have more light out of the LEDs, the efficiency goes down. So such efficiency droop actually prevents the LEDs to be used for the everyday lighting.
Stadium lights, anything like that will directly benefit from his invention.
For the droop, we want to focus into the LED where the light is actually generated. It's they call the active region. So the conventional active region has a polarization mismatch problem. So such polarization mismatch will tilt and twist the band diagram. The electrons will leak out of the active region. That's why the efficiency drops. For the solution, I'm using new materials to match the polarization in the active region so that the carriers can stay and emit the light rather than leak out.
In the future, I would definitely like to continue to do research.
And any new problem, any interesting multidisciplinary new problem.
In the long term, I would like to start my own business, be an entrepreneur,